Hello there, Hackfort. How are you all doing? All right, thank you, ladies and gentlemen, both of you. My name is Crispin Gravatt, and I am the Senior Research Analyst and Strategic Change Liaison over at the Idaho STEM Action Center, where we focus on science, technology, engineering, and math education and workforce development all across the state. And I am very, very pleased to be here with three very special guests to talk about digital literacy and digital literacy education. So, guests, hello, how are you? I will let you introduce yourselves and tell us what you do for your day job. And let's start over with Marcus.
Hello. Oh, that works. Is it too loud? Hi, I'm Marcus. I work at a company called STEMforged, and we are making 3D game design software and esports programs for schools.
Awesome. Passing it on down.
Hi, I'm Lindsay Davis, and I teach computer science at Boise High School.
Hello.
Not least.
I'm Ashley Byington. I am Chief Sales and Marketing Officer of STEMforged also. We do video game design and esports programs for schools.
Excellent. Well, thank you all for joining us here today. So we all are involved in the world of digital literacy, either as recent graduates from Boise State University, is that right? Or from the education perspective or from the business perspective. So tell us a little bit about how you got to where you're at in this space. And let's start one more time with Marcus. What's your journey?
Why do I have to start? Well, to be honest, we set out 2016. Remember the big VR revolution that then didn't happen? We set out to make a virtual reality scene design software that we plan to sell big time to what Facebook now is sinking $2 billion in per quarter. So you would call it a metaverse software or metaverse studio software these days. Turns out that was really highly sought in schools because schools were kind of like doing a 2D game design thing with what is called Scratch. Who here has heard of Scratch? Okay, Scratch is from MIT. It's a free software that has a cartoony little 2D interface and can make like 2D cartoony games with that, teach the beginnings of coding and logic for kids, right? It's been used all the way down to elementary school because it's so simple to use. It's also mind-bogglingly boring if you're like a self-respecting middle schooler or high schooler. So when we came in with our 3D software, the high schoolers and the middle schoolers got really excited. And they were like, well, we are our customers, not those guys. And that's how I got in the space. And we improved it for schools since then.
Awesome. All right, Lindsay, how did you land where you're at right now?
Nice. Well, I started my career as a physics and math teacher, and I didn't even really know what coding was or know much about computer science until I heard about Boise State's I Do Code program, that the purpose was to train more teachers to be able to teach computer science, basically. And so I decided to go ahead and do that, just not really knowing what I was getting into. And it was definitely an intense experience to kind of start learning computer science in my 30s when I really didn't even know, what was going on. But throughout that, I found that I really had a satisfying experience learning how to code and learning more about computer science and feeling like I can learn something new that felt very applicable, even, once I had felt like I'd finished my schooling. And every time I got the opportunity to do something with high school students that related to computer science, they got so excited. They could really see the purpose of doing this learning. And so when a job opportunity became available at Boise High School to teach computer science there, I jumped right on it. And I've been doing that for 5 years now, and I really enjoy it. And then another aspect of my work right now is I also work with code.org, which is a curriculum kind of a content provider. And I train other teachers how to use our curriculum and also just, best practices to welcome new computer scientists into the field and to really make it as open and accessible as possible. So I'm really proud of that work that I do with code.org because it helps make it gives students exciting curriculum, and also it gives teachers something they can use in their classroom that I think is a well-designed curriculum. And we're going to get to see some student projects later on that I have ready for you guys to check out.
Little teaser. Can't wait. All right. And then Ashley,
Yeah.
how did you land where you're at?
Yeah, so I started out as like a traditional artist. So I was a painter, drawer, colored pencils, all that stuff throughout high school. And then when I was moving to graduate high school and trying to think of what I wanted to do in my future, I actually originally went to Boise State for illustration. But at the end of the day, I didn't really want a traditional art degree. I wanted to see where else I could go with it. So I found the Gaming, Interactive Media, and Mobile Technology program at Boise State, GIM. And that interested me because I wanted to do more with my art, like animation, 3D modeling, and these sorts of aspects of game design really intrigued me. So once I got all of these new skills, tech-wise, and combined that with my art experience, it really opened up a lot of doors. I did start my own creative agency, and I was successfully, doing a lot of branding, which, isn't necessarily a STEM field. But what I did use was take all of my game design experience and that content creation, digital literacy aspect of it. And I combined those kind of worlds. And what I specialized in was animation and animated logos and making GIFs. That was very fun. And then now I'm kind of in this game design adjacent sales role, where I really just get to advocate for STEM students all over the country. I get to advocate for the nerds. That's really all I try to do. Give them more opportunities.
It's pronounced GIF. And I do believe that GIM has a table over in the room on the way out, so stop by if you haven't already. So I'm really curious about your experience in GIM. How did you learn about that program, and what was your initial draw into that space?
Yeah, so my initial draw into GIM was that I feel like I was very creative, but I was very analytical, and I wanted to combine those worlds. So GIM interested me because it was very project based, and it was just a lot of different things happening at once. You have the artistic side. You're doing coding. You're doing working together as a team to build these projects. At least in my experience in GIM, this was the very beginning of GIM when I was there last. Yeah, disconnected. This one's connected? Perfect. So yeah, that's kind of where I came into GIM. It was a place for all of these different interdisciplinary kind of topics that you could learn in another field. You could do computer science, you could do traditional art, but GIM kind of combined all of that.
Very nice. And so it sounds like that word interdisciplinary is really the appeal as a student coming into the world. And so how has your teaching experience, Lindsay, been incorporating all of these different elements into digital education?
I have really enjoyed it. It has given me more excitement as a teacher. I used to teach physics and math, and especially math. I found that students didn't really love that class. And so being able to teach something that has just a lot of different applications and whatnot has kind of revived my excitement about my career, and just kind of given me just the opportunity to give students more options to go into. As you were talking about GIM, I've had, the GIM people come out and visit my classroom several times. And many of my students who were like, I just kind of took this class and I didn't know what it was. And many of them are actually now going into the GIM program. I have like 10 or 15 students who are going to be going into that program, or who are choosing to major in computer science in other programs at other schools. So it's really helped me to just kind of, get some more excitement about my career. And it's so great to see students excited about what they're doing. So I've really enjoyed that aspect of it.
Yeah, it's almost like I always think about how playing Pokemon growing up really tricked me into doing math. Mm-hmm. So it sounds like
yeah, Minecraft is a big one.
Minecraft, yeah. So as we're learning all of these skills through excellent instruction, Marcus, what are some of the in-demand skills and competencies that you see in your work for future employees to prepare?
Right. So when we teach game design with the software that we are making, there is something that software game developers, which you think about it like this. They're teaching how to make games. So the result is someone who can make games. But nobody really thinks much further. So who here knows video games? Who here plays video games? Okay. That's almost less hands than I thought. So in video games, or among video game developers, we have the same problem explaining this to people around us, which is like, what is it that you actually do? You're not like making the game. So there is something that is known to be the door problem. If you want to Google this, game design door problem, it explains the role of doors in video games. If you're playing video games or just know how video games works, you can see at one point you come to a door. Now, there's a person that in a big game developer team that designs that door. There's a person that decides if that door should be open or closed. There's another person in that team that decides what sound the door should make when you open it. There's another person in that team that decides if you need a key to go through this door or not. There is another person in that team that makes sure that that door doesn't destroy the game's performance. There are people in that team that are testing the door if it actually works as designed. There are people that are program managing that team to make sure that the whole door thing, and we're talking about one door in a video game, which is like that tiny small subset. So if you Google the door problem, you will actually find a list with over 100 different jobs, completely different, seemingly not affiliated jobs that are needed in such a team just to program this one thing, to get this one thing going in a video game. And now with the advent of VR, AR, all those things, that's 3D game design at its core. Because if you have an interactive 3D experience, which you can see outside at Intercon and all the others, I just skinned an elk this morning. Efficient game experience that the GIM students made for them because they feel like that hunters in Idaho don't know enough about how to properly do this. So they commissioned a project with them, and you're in 3D and you have a virtual knife and you're skinning this thing. And I will forever remember that you actually started at the hind legs for this. This is what VR does in training, right? You memorize something very fast, and that's what is happening. Intercon does this for complex machines. That's not a video game, but you need exactly the same components, and you need to have all those people on those roles to create this safety training that they have out there. So there is a myriad of jobs associated with 3D design.
Well, I'll never look at a door the same way again. And with over 100 jobs involved in just the door problem, it sounds like one of the key competencies is like communication, teamwork, collaboration, in being able to create a product, whether that's a game or other kinds of advanced technologies. And so I'm curious, Ashley, I have this idea of an artist in my head, a visual artist, as sort of a solitary figure. Like, don't look at me during my art process until I have a finished product that you can see. How has the jump to digital art challenged maybe that assumption and helped develop that sort of sense of teamwork and collaboration in your experience?
Yeah, coming from that traditional art background, you do work very alone, and you ask occasionally for somebody's feedback, and once you're a certain way along in the process. But then jumping into GIM, where almost everything that we do is a team project. Mm-hmm. And so, having to kind of give some of that up and earlier in the process than I normally would. I think that I've never had worked on a team like that before. And I've always been an art kid. I've never done a sport really. So yeah, that was kind of one of the first experiences that I had professionally working in a team that way. And I do think that now that I'm in a sales role, even all of that communication, even though I'm now just STEM adjacent, it's very much still there.
Mm-hmm. Mm-hmm. Awesome. And so I wonder in the classroom as well, is there something like a door problem that is an opportunity for, the loner art students or the star athlete to work together that draws out a certain magic?
Yeah, and so this is something that we do try to give students the opportunity to work together and to work on a team in the classroom, which is something that oftentimes high school students signing up for a computer science class, they are expecting to maybe get to just, be in a quiet room on their computer all day and to not have to talk to any other students. Sometimes, that's sometimes the group that we get. And so it is kind of one of my jobs as the teacher to get students to talk more about their process and to learn not to just write code that goes, but to be able to explain why it works, to be able to write a function that can fit in with somebody else's overall program and to make something bigger work that you've only done a small part of. And so that is something that we do try to do at the high school level, is to give students the opportunity to work together and to, put their ideas into words and to learn how to, just how to kind of create a finished product working as a team, as opposed to, the thing I have to kind of get them to not do is to wait till the last night and assume they're going to be able to do it all by themselves in the middle of the night before it's due, because working as a team, you have to get started earlier so that you can communicate with each other. But I do enjoy seeing what my students come up with, because when we have kind of hit that magic where they're working as a team, those are oftentimes the coolest projects that I've seen. And I also think the most meaningful for the students, because they had that experience of working with other people.
Yeah, and I don't want to jump the gun if you want to save your student project examples, but what kind of work have your students been able to achieve in this sort of different style of teaching and learning?
Yeah, so we can actually click through it if you'd like to, and then these will all be something that you guys can come up and click on a little bit more. But this right here is one of the first projects that we do, where students are just, these are first year computer science students who have maybe never written a line of code in their life. And we don't start off with coding. We actually start off talking about how binary numbers work and how, everything can basically be turned into binary. So we learn about RGB color encoding, and students create their own color palette and then make, basically we call it a favicon, some sort of a personal logo. So this is a really fun, we do this in the first week or two of the school year. And then I hang them up and hang them outside of my door, and students point theirs out so that other students can see theirs. And then if you click ahead, then we get into doing some different projects and whatnot. This was one of the projects where students are just basically learning conditional logic, like if-else statements. And so they're checking on things that people have told them and then have to do, some logic and whatnot. This one about the pizza, this group of boys got so into this, and they just made this silly little app that just basically asks nonsense questions, and then they somehow come up with how many pieces of pizza are you worth? But these kids had such a great time, and I really think that some lifelong friendships may have been forged as they were working on this project together, just because, it was just such a fun time for them. And this was also during COVID, when we were kind of, just emerging and kind of learning how to make friends again after they'd been home for so long. So that was a really fun one for some of the students. And then you can click through the next one. This is a pretty cool project where we get to import data sets that they can then basically practice doing, traversals and looping through the data sets and doing something with them. So this gives students, we have some that are more mathy science type data sets, or ones that are about birds. We have ones about all the Netflix content. So students get to kind of see how to manage big data and how to create cool stuff out of it. And I think the very last one here is just basically the final project where they can do kind of whatever they want. So one student kind of made this bug collector type thing. And then this other student, he was into kind of translating stuff back and forth. So so those are just some examples. I really just love seeing my students, their creativity. I feel like I get to know my students much better by seeing the types of projects they get to pick. And also, I think they just have a lot more buy-in, because it's okay, show me that you know how to, work with loops or whatnot, but they can, make really a project about anything, as long as they're, using certain CS constructs.
That's awesome. Yeah, it's really impressive to see that computer science education has come a long way since I was in school, and the extent of that was Mavis Beacon teaches typing, and I'll never forget those games. So I want to make sure that we have some time for Q&A and then some time to run through some of the learning tools that we brought with us. So the last round of questions for all of you, and I'll start with Ashley this time. What is your why for being in this world, and how do you see digital learning building better artists, mechanics, thinkers, and citizens in your experience?
Yeah, definitely. So I think what it really comes down to is that digital literacy and content creation at this point are in any field that you go into. And getting kids to learn that from an early age in like a safe, healthy, in a safe, healthy environment where they can have these experiences where they get to work together in a way that maybe they hadn't before. Maybe they've never played. Maybe say there's an esports team. I think that's another great opportunity to bring that up. 80% of kids who play esports go into STEM careers, but a lot of these esports players who play games at home by themselves or play online with who knows, and now they get to come to school and they get to find their tribe and they get to have that teamwork and collaboration and then they learn how to make their own video games. So it all it very much comes full circle. But even if you are some farmer, I don't know, at some point you're still gonna have to do content creation because that's the world that we live in. And so that's how I think that digital learning where it is right now is improving to make better professionals in every field.
Awesome, thank you. Lindsay, what's your why for being in this world and going above and beyond in your roles in digital education?
Yeah, I think my why is that I think it's really important for high school students to have some sort of an exciting experience where they feel how much fun it is to learn, how satisfying it is to really understand how to do something. And I feel like computer science is the perfect, way to have that experience. That also gives you really great job skills. Like you can get, a job in tech and, a high paying job where you can have a family and, kind of have a good future in front of you. Another aspect of my why is that work that I do with code.org as a teacher trainer, because a lot of teachers are thrown into the computer science classroom without much background. I was really lucky to have actually taken some classes at Boise State ahead of time, but I know many teachers who are just like, oh, I've been told I'm teaching computer science next year. And so I think that giving them high quality content that just allows them to feel like they can do a good job with their students is really important too.
Awesome. And last but not least, Marcus, what's your why?
Can I run a really quick thing with everyone?
Sure.
Okay. Who has seen or heard of the big AI revolution happening right now? Okay. Who has experimented with anything AI generating? Almost same level. Who has created an image using AI? Less. Who has created music with AI and has listened to it? 2. Okay, so this is essentially the world that we have right now, and we're all lucky and I guess privileged enough to sit here and go yeah, I've heard of this and I have access to this. The kids often don't, and that's why we are here. We have trailblazers. Creating music is a niche AI product and will be all over the place the next year. Not everyone has used AI at this point, but in the next couple of weeks, it will be updating Microsoft Office, Google Drive. Adobe has just released a huge AI suite. And that's the same thing. So the trailblazers blaze the path. We want to identify those in the schools and give them a chance to shine, right? But then also there's people who just need to use this because it will be a huge change. And if you use technology right, it can boost your productivity, can make you better with what you produce. And we want to give the kids that chance as well. And finally, if you have never used it, at least you have been exposed to it in the place that, we all enjoy being exposed to because we have our connections. Kids get most of their knowledge from schools, or if they're lucky, from their parents, and want to take the luck out of this equation.
Well, awesome. Thank you, folks. And right now, I will open it up to Q&A in case any of you have any questions, comments, concerns, or threats.
First of all, thank you for all that you do. Oh, God. All right, is that better? Okay. First of all, thank you for all that you do for the next generation of technologists. Very much appreciated. So I'm a very senior level technologist in a very, very large bank here in the United States. And I mentor and work with a lot of entry level and mid-level engineers, software, hardware, and so on. And so all the skills that you're talking about are all really relevant and very happening now, right? But I want to ask you about some soft skills. So one of the areas that I noticed that young engineers coming into the field really need a little bit more experience in is communication of the ideas, being able to pitch what their ideas are, as well as working with and collaborating with other folks in a team. Often those are the most difficult things to teach the young engineers coming into the company.
Yeah, so I'd love to speak on that actually. So one thing that I'm a big proponent for is esports. So a lot of these kids who play video games, like I said, go into the engineering field, go into STEM careers. But what esports can do, especially in the schools, is exactly that. Is they're doing something that they love, and they're finally pulled into an activity in school that they might not otherwise have participated in. And they're learning how to communicate with each other. It's like these social emotional skills. There's so many hypotheticals that you do, like it's all very hypothetical in traditional SEL programs where like you know they go to the school and it's like, what happens if your brother kicks you? And you're like, not kick him back. Like, what am I supposed to say? You know, with esports and playing video games in general, you get to experience those things as they're happening. So learning how to communicate with each other, say Rocket League. Have you ever played Rocket League? No. So Rocket League is a game where cars play soccer. And you have to communicate with each other to say like, okay, the ball's in the middle. I'm the closest to the ball. And so I'm going to go ahead and get it first. And then, okay, I'm going to stay back here by the goal. It's just like a kind of what you would need to do with a traditional sport, but it's teaching these kids who maybe aren't ever going to join a traditional sport or a physical sport, the same kinds of teamwork and collaboration and communication. Yeah. So I love talking about esports. So that's why I think that there should be more esports in schools.
Anything else from the two of you?
I will say that is one of the harder things to teach, the soft skills of getting students to communicate with each other. And, you know, I mentioned a little bit of like coming out of the pandemic a little bit before, and it's been even harder, honestly, the last year or two since, you know, kids were gone on virtual school for so long, and like kids have gotten a lot more used to, they almost feel more comfortable communicating via text or, you know, like on like messaging apps or in some sort with each other. So I have kind of played around with having students like have shared Google Docs where they like put ideas and to just, you know, just get them communicating that way. I've also worked with other teachers at my high school, because this is an across the board, not just in computer science program. We're all finding that it's like, how do you get kids to talk about this English essay they just read or this, you know, history thing that we're trying to discuss. So we've even worked on doing like sentence starters for students to just kind of, you know, give them almost like fill in the blanks just to kind of learn how to start a conversation about what to do next. You know, like, I think you have a good idea, but let's try this next, like things like that. Because I really do think that that's important all the time. But even right now with this group of students, you know, just post-pandemic, they really do need some help learning how to talk to people and face-to-face again. Yeah.
Awesome.
I've been invited to Marsing, small rural school district right outside of Nampa, to a game design class from a teacher who's been using our game design program. And I go in with all my theoretical knowledge, and they teach our game design how to build a maze to the kids. Kids about 5th grade, 6th grade, after school program. And so I'm like, okay, that works great. Kids were excited. They were building mazes. And I'm like, so in our curriculum, we suggest to give you about 10 to 20 minutes for team play afterwards. And he just looks at me and goes like, no, we give them 3 hours. And I'm like, okay, why? Because our theoretical suggestion is, of course, the best one out there, right? Well, he goes like, no, it's not, because look at this. And he lets the kids go like, okay, guys, let's play each other games. So all those kids design mazes. And like 5 minutes later, I was in the loudest class that I've ever been. And that's okay for after school programs. Like there was a group of kids surrounding one kid to make sure that that kid doesn't see what the other group of kids is building just for them as an alternate version of their maze. So they took 5 minutes to build that maze while the other student was waiting and shielded from that team, so that they student is supposedly like the best player in class, and they built an impossible maze for that student to then play. And then 5 minutes later, they were ready, and the whole class was like just holding their breath, like watching that play. And then it was very, very loud again. So if a teacher runs a game design program like that the right way, it is extremely communicative, because that's just in the nature of this, right? They play a video game that someone else like just next to them made, and that's just really awesome.
Well, awesome. Thank you, folks. To make sure that we have enough time to use some of these tools ourselves, I think that we will transition now to a few different stations where we will have some examples of student projects, of some of the software employed in this practice, as well as some physical hands-on tools. So we'll take a quick beat, and feel free to...
So Marcus and Ashley are going to be over here on this table, and then myself and Lindsay are going to be up front, and then Crispin's going to be back here with some play type stuff. Feel free to ping us. We're here.
Yeah, come, play, learn. Insert transition here. Thank you all.